Okay, so today we're looking at using something called the trigonometric addition formulae. You can find these in the formula booklet, so you don't need to remember them. But when you look at them, what they actually are is like this, but exactly what that looks like in the formulae tables is this. So we've got stuff doubled up. So we've got sin of angle A plus angle B being sin A cos B plus cos A sin B, and then we've got sin A take B is identical to sin A cos B take cos A sin B. Now that's simple enough, but you do have to be very careful with cos, because if you look here we've got cos plus or minus, and then that becomes minus plus, and if you look up here, when you're adding the angles in cos, you're taking sin A sin B from cos A cos B, and when you're taking them then you add. And a similar sort of thing happens in tan. Anyway, just going to take you through a few examples of how these can be used. These identities can be proved using geometric constructions, but you don't need that for the exam. You just need to be able to use them. So looking here where we've got sin A take B, we need to show using the formula, so that's up here, that sine 15 is equal to that. So we're going to start off by picking two values that we know that would give us 15 degrees. So some of the things we know sine 60, that's one of our values we're meant to remember. We don't have to remember it because we've got the calculator, and we know 45 degrees. We also know 30, so we could do 45 take 30 and we would still get there. Anyway, carrying on, I'm going to copy down from the formula there. So this would give us sin 60 times cos 45 take cos 60 times sine 45. And at this point you need to remember what the values are. Easy mistake to make sure you don't make is make sure your calculator is in the right setting, because if you put sin 60 and get that out, that means it's in radians instead of degrees. So moving on down, you should have root 3 over 2 for sine 60, and cos 45 is root 2 over 2. Cos 60 is a half, and sin 45 is also root 2 over 2, because of course the 45 degree triangle is, when it's a right angle triangle that we're thinking about, is an isosceles, so sin and cos turn out to be the same. And now all we need to do is work these through. So that's going to become root 3 times root 2 is root 6, and that's all over 4. And then if we multiply 1 by root 2, you get root 2. 2 times 2 is 4, and that is the same thing as root 6 minus root 2 over 4, which is what we were asked to do in the beginning. So we can just put as required, and that's that one done. Right, next problem, write it down. See if you can have a bit of a go. Have a look, take your time, pause the video, and then come back and check that what you've done goes the way that I. Okay, so it's saying, given that sine negative 3/5, sine A is negative 3/5, and A is between 180 and 270, and cos B equals negative 12/13, and that B is obtuse, we need to find the value of cos A minus B, tan A plus B, cosec A minus B. So let's just deal with cos A minus B first of all. So we know that's going to need us to use cos A cos B. So it's going to be cos A times cos B. Well, we've already got cos B. Let's just put that in straight away. And then we're going to be adding, because with cos it's minus, then you have to add on the other, then it's sine A, which we know is negative 3/5, and we're going to multiply that by sine B. Not sure what that is yet. So we need to work out what cos AR is and what sine B is. And in order to do that, we're going to need to use one of the trig identities that we should know all the time. That's going to be good old favourite cos squared theta plus sine squared theta equals 1. And we can rearrange that, can't we, to say that cos squared theta equals 1 take sine squared theta, and we can do the same thing for sine. But so if I'm looking for cos A, I know that sine A is that. So I'm going to say cos squared A is going to be 1 take sine squared A, and we know that sine A is negative 3/5. So that means that cos squared A is going to be 1 take 3/5 squared is 9 over 25. And that's quite nice, because 25 take 9 is 16, so that's going to give us 16/25. And the reason that's nice is they are both square numbers, so when I do the square root of both sides, I'm going to get cos A is equal to plus or minus 4/5. Now, the problem is it can't be both. I need one value to go in here. So the next place to look is where the angle is between. So I know I'm dealing with cos, so I'm going to just make a tiny sketch of the cosine curve, and I don't want it all the way from 360 to 360 like I've drawn it. I just need it from 180, which is there, to 270, which is there. So that whole region is negative. So for that reason, I know that cos A must be negative 4/5. And then I'm going to do a similar thing for to work out what sine B is, because I can say that sine squared B is going to be 1 take, and cos B is negative 12 over 13, so we're going to square that. So that's going to mean 1 take 12 12's 144, 13 13's 169, and nicely, if we take 144 from 169, that gives us 25 over 169. I say nicely because that means that sine B will be plus or minus the square root of 25 over 169, and the square root of 25 is 5 and 169 is 13. So it's plus or minus 13. Again, I need to know, is it positive, is it negative, and I can just do my sine curve here, and we want it's obtuse. So obtuse is between 90 degrees and 180, so it's this little bit here, so it is positive. So therefore we know sine B is 5/13. Now that I've got those two values that I need, I can write out again cos A take B is going to be identical to negative 4/5 times negative 12 over 13 plus negative 3/5 times 5/13, and that's going to equal, well, the negative times the negative is a positive, 4 12's are 48, 5/13's are 65. We'll keep it as 65ths, even though we could cancel so that we've got the same denominator. Oh, and it's a negative, isn't it? So that means instead of adding, we're going to be taking. And 3 5s are 15. 15 from 48 is 33. So our final answer for cos A minus B is 33/65. And you may be thinking, why couldn't I just find out what the size of the angle A was at the beginning? If you did that, you wouldn't get it as an exact value, so you'd always be dealing with stuff that was rounded. Right, next up, going to be doing a similar thing for tan A plus B. For tan A plus B, the formula booklet will tell you this, so it's tan A plus tan B over 1 minus tan A tan B. We haven't been given the values of tan A and tan B, but we can work them out using the other really early identity that we learnt, that tan theta is sine theta over cos theta. So having told you that, pause it, have a go, see if using all the values that we've worked out in part A, you can get there. And I'll run you through my working in a moment. So as a first step, you should have this. To find tan A, you take your sine A, which was -3/5, divide it by your cos A, which is -4/5. Do it with the calculator or by stage change flip, gives you 3/4. Then do the same process for tan B, being sine B divided by cos B, gets you -5/12. Then all we've got to do is plug those into here, and you can put this all in one big fraction inside your calculator. So do that, have a go, pause it and then see if you get the same as I'm about to. So I've got 3/4 plus -5/12, and then I've got one take, and it is 3/4 times, because it's tan A times tan B, -5/12. Whack that all in the calculator and see what you get. And it should all come out as 16/63. And you can show more working in between that if you want to, but you don't have to. Now, the last one, part C, was cosec A minus B. And cosec, if you remember, is 1 over sine, isn't it? So that means we're saying it's going to be the same as 1 over sine A take B. So we are going to do the whole, we're going to work out what sine A take B is, and then just make it the reciprocal of that. So pause the video and have a go. And always start by writing it out, just to make doubly sure you've got everything right. So it's sine A cos B, and we're taking cos A sine B. Plug in the values that we know. So we know that sine A is -3/5, and we're multiplying that by cos B, which is -12/13. And then we're going to be taking away cos A, which is -4/5, multiplied by sine B, which was 5/13. And if we do that, then that's going to give us, what is it, 3/12 are 36 over 65, and we're going to be taking a negative, so we are basically going to be adding at the end of that 20/65. So that's giving us 56/65 as sine A minus B. Now 1 over that is the reciprocal, which means that 1 over 56 over 65 is the same thing as saying 1 divided by 56 over 65 is the same as saying 1 times 65 over 56. So it just means that it ends up being 65 over 56. Just flip it over, the reciprocal. Okay, now that is all the examples for today. Now you just need to have a go at practicing this. So exercise 7b, page 173, questions 2, 3, 5, 10, and answers are on page 393.